For 8.4, 8.6, Review 1, we're going to look at our second page. This is something involving the properties of logarithms. And I've actually written the 3 properties of logs that we've been using at the top of the screen. The directions from number 6 means to expand. And that means to write one log as an addition or a subtraction of many logs. Perhaps 2, 3, or even 4. The exception, of course, is with A, where we're not going to be able to write that as an addition. We are just really asked if we could use that property where you can drop down the power. And we do that quite a bit. So we'll say 3 log of x. For letter B, though, however, I hope you can see there's a multiplication of 5 and x. And if you look at your first property here from the right side, if you are dealing with a multiplication of terms inside, you can turn that to an addition of 2 logs. This would become the log of 5 plus the log of x. By way of comparison, when you look at letter C, you're going to see that that actually has a division of terms, making a fraction. That's property number 2. You can see that fraction right there. This is always going to involve a subtraction. We're going to have the log of 2 minus the log of 3. Now I do want to point something out, and this is very, very helpful for later problems. What is down below here is going to always have a negative in front of it as we expand. You're going to notice we have a minus log of 3. The numerator is always going to be left as a positive. And even in letter B here, if you think about it with that 5x, really the 5 and the x are in the numerator. You could put them over 1. They're always going to remain positive. What am I getting at? Well, look at D. You see 3 terms inside of your log. You have a 3 and an x, they're up on top, and you have a 4, which is down below. We could rewrite this as the log base 2 of 3 plus the log base 2 of x. These terms are up on top, they're positive. The term down below we could write minus log base 2 of 4. And that's going to be our final answer. So just pay attention to what is in that denominator. That's always going to have a minus go out in front. As we look at letter E, you're going to see once again that there are multiple terms. There are actually 4 distinct terms inside of the log. This means that we're going to write 4 logarithms. The terms up on top will be positive. We can write the log of 2 plus the log of x squared. But there are 2 items down below, and I can say minus the log of 3 minus the log of y to the 5th. Next, take any powers that are present and drop them down. And hopefully you can see that we'll bring the 2 out in front where we had the x squared. We're going to take our 5 and drop that down in front over here. Let's recopy our answer. But like I said, we're going to have 4 distinct logs. We had 4 different terms inside. Pay attention again. The minuses are relating to terms that were in the denominator. Anything that doesn't have a minus is implied to be positive, or you can see a plus out in front. Those terms are in the numerator. Well, with 7a, the addition of 2 logs, you can see up on top is going to be property number 1. And that, of course, is just going to become the natural log of x times y. Property number 2 involves the subtraction of 2 logs. That's what we see in letter B. This will become the log of 6 over 2. Now you can leave your answer like that, and that's fine. However, 6 divided by 2 is really just a 3, and it would reduce to that. We could also take for letter C, we could bring our 2 up, condensing, and we'd have log base 4 of 5 to the second. But we know that 5 to the second is actually 25. If you wanted to leave your answer as 5 raised to the second, though, that's okay. For D, if I gave you the log base 2 of x plus the log base 2 of y, this should look amazingly close to answer A. We'll have the log base 2 of x times y. We're just changing our logarithm. Here, we're going to take the number out in front and raise it up high as an exponent. And then you'll notice we have an addition, no minuses, so nothing will ever be down below, everything's up on top. This addition implies that we are multiplying x to the third and y to the second. It's really our first property. Taking a look at number 8, the loudness of a sound really has this formula. The intensity of the sound in watts per square meter is I, and L stands for loudness. So the loudness here is going to be 10 times the log. Well, the I value, the sound intensity, is 3.162 times 10 to the negative 6, and down below we'll have 10 to the negative 12. At this point, let's go ahead and just get this typed in. We'll type 10 log. I'm going to hit alpha y equals, and then we'll type 3.162 times 10, raise that up to the negative 6th power, bring this down, and we'll have 10, raise that up to the negative 12. Could close your parenthesis if you'd like. You'd see it's about 65 decibels. 64.999. Finally, on this page, we have a pH, the power of hydrogen. In chemistry, it's simply the negative of the log of the hydrogen ion concentration. So the pH for Coca-Cola will be the negative log of 3.5 times 10 to the negative third. And what we can do very fast here is just type in negative log 3.5 times 10, raise it up to the negative third. When you hit enter, you'll get about 2.5, roughly about 2.5. That is indicating that Coca-Cola is very acidic. That wraps up page 2. We'll be moving on to our third page in the next video.